Alright, hello everybody. Today we're going to be moving on to the second main topic for Unit 3, which is chemical reactions. We learned a little bit about them in the first unit, sort of how to identify them and stuff like that, and how to classify chemical changes, as well as we've looked at a couple of them specifically for acids and bases. But today we're going to talk about them sort of more generally and the different types. So let's get started. So, what is a chemical reaction? Well, we've got our sort of lengthy scientific definition here, which is that a process in which physical and chemical properties of the original substance change as existing bonds are broken and new bonds are formed, producing new substances with different physical and chemical properties. Okay, so this describes things that you all should be used to from Unit 1, but to give a more colloquial definition, this is a process that forms one or more new substances. Okay, so this is a little bit of review from Unit 1, but evidence of chemical reactions include a change in temperature that is caused by the reaction itself. Remember, melting something is not a chemical reaction because the heat required is coming from outside, and even then, remember, temperature doesn't change during a phase change. An unexpected change in color, a change in odor, formation of a precipitate, or formation of a gas. And once again, formation of a precipitate means it's when you pour two liquids together and solid stuff precipitates out and suddenly forms in the solution that you have. And usually, settles down to the bottom of whatever reaction vessel you're using. Alright, so that was just a bit of review. So, when we talk about chemical equations, we talk about a couple different things. All right, so if I have an equation that looks like, A plus B yields C plus D. All right, the reactants are the substance that's consumed, so that's the things that are on the left side of the equation. The products are the things that are formed. Those are on the right side of the equation. A catalyst is something that speeds up a reaction but is not consumed. That is typically written up above the arrow. Okay, like manganese oxide. A coefficient is a number that shows how many molecules of a substance are consumed or produced. So these coefficients are the big numbers that go out front. So, like if I said there were 2A, that would be a coefficient. Remember, the numbers down here, like if I said it was D2, those are not coefficients, those are subscripts. And then physical state, which is not something we've seen before, but you've seen it in the acid and base equations that we talked about. So if I had like sodium plus calcium chloride makes something else. These things are the physical state. They're usually written either as subscripts or just after the chemical formula, and they just have a little letter or two letters in parentheses, and this just describes whether it's a solid, liquid, or gas, or AQ, which is aqueous, which just means that it's dissolved in water. Okay, so this is something you can distinguish where, if you have a precipitate forming, it'll form something that has a little solid S after it, rather than continuing to be aqueous, for example. Okay, and here's an example of these things.
Remember to keep in mind the difference between a coefficient and a subscript.
And again, we have here the physical states where that nitrogen is solid and that oxygen is a gas. Okay, and if you're saying a reaction out loud, like saying it in the form of a sentence, this arrow in the middle is kind of said as yields. Right? So, to give an example of how to sort of convert between a word equation and a formula equation, we have this one. Calcium metal reacts with oxygen gas to form calcium oxide. Okay, so if we were to write that, we would have calcium metal, which suggests that it is in solid form, reacts with, so we had a plus, oxygen gas, so oxygen, which we know is O2, and it's gas, so we write a little G in parentheses, to form, okay, so now we're talking about the products, calcium oxide, and this doesn't say whether or not the calcium oxide is in solution or not, but if it's important it will, but let's just, for the sake of it, say that that's in solution. Okay, so in this case, okay, it wasn't in solution. We have the formula down there and it is balanced, which is something we'll talk about in the next lecture, so don't worry about coefficients right now, but that is how you sort of translate in between these two things. All right, and here's another one. Water decomposes into hydrogen gas and oxygen gas. So that decomposes into is kind of your hint that you need to put the arrow there. And so we have water, which, unless otherwise stated, is always going to be a liquid, making a hydrogen gas and oxygen gas. So we know that they're both going to have that G after them. All right. So there are 5 types of chemical equation that you need to know and that you need to be able to identify. Okay, and so these are now on the back of your notes, and we're just going to go through them and give examples of each. All right, so first up is synthesis. Synthesis is when 2 or more reactants form one product. Okay, so synthesis is easy to identify because of this thing right here, one product. All right, so if you see a chemical reaction that has only one product, you can go ahead and label it as synthesis. All right, and synthesis reactions have the form A plus B makes AB. All right, where these are sort of placeholder elements, although I guess B is boron, that combine to form just one product. There should only be one thing on the right side of the equation. And so you've got 2 examples down here, where again we've got 1, 2, but over here we've only got one compound on the product side. All right, so that's synthesis. All right, decomposition. This is kind of the opposite of synthesis. This is when one reactant, again, one reactant forms 2 or more products. All right, so once again, this is easy to identify because you only need, if you see only one thing before the arrow, only one reactant, you know it's decomposition. All right, so over here we've got KCl, one thing that makes more than one thing. It's decomposition, and it has the general formula AB makes A plus B. So this is basically the opposite of synthesis, like I said before. All right, next is single replacement. All right, this is when an element in a compound react to form a different element and a different compound. So the example here is it's AB plus C makes AC plus B. So basically what's happening is C is kind of coming in and replacing B in the compound. So B gets sort of shunted off by itself, and the new compound is A and C. This is why this is called a single replacement, because there's only one replacement going on, and you've got these sort of uneven pairs of a compound made of more than one element and one element by itself, right? So examples like that are, here's zinc by itself and copper sulfate, which is made up of copper and the sulfate polyatomic ion. And then you can see the zinc replaces the copper, and the copper is off by itself. Okay? Alright, next up, double replacement. This is basically the same principle, except we've got two compounds swapping parts, basically. Alright, so this is two compounds react to form two different compounds. So we have a form that is AB plus CD yields AD plus CB. Okay, so you can see that in this case, D and B got swapped and replaced one another. That's why it's called a double replacement. Okay, so examples of this are, we've got some calcium chloride and silver nitrate, and the nitrate polyatomic ion and the chlorine swapped with one another, and the silver and calcium stayed in place. That was a double replacement reaction. Okay, examples of this that we know are, again, those neutralization reactions, right, where we had like a base and an acid making water and a salt, right? This is a double replacement reaction, right? Because the Cl and the hydroxide ion, in this case, swapped with one another, and so we've got H2O, which, keep in mind, is HOH, right? And then we have NaCl, where the chlorine has come over and replaced the hydroxide. All right. Last one is combustion. This is a kind of a more specialized kind. This is a hydrocarbon reacts with oxygen, producing carbon dioxide and water. So we've seen oxygen, carbon dioxide, and water. You may not be completely familiar with what hydrocarbon means, but a hydrocarbon is just one of those molecules that we've seen before that has C, H, and maybe O with, different subscripts on them. Okay, so methane, CH4 is an example. If it's got C, H, and O, it's a hydrocarbon, and it doesn't need to have the O. All right, so here's an example. Got methane reacting with oxygen to create carbon dioxide and water. Right, and there's our written out equation. And here's another one where our hydrocarbon has an oxygen in it. Okay, this would be ethyl alcohol, I believe. But it's just something with CH, CX, HY, and possibly OZ, plus oxygen, which makes carbon dioxide and water. Really, the products here are how you can most easily identify combustion equations, because if it ends in carbon dioxide and water, it's going to be combustion. Okay, so that is all the different types of equations that we need to know and need to be able to identify. And next up, we'll talk about how to balance these equations, how to do these numbers out front. But until then, I will see you in class.